What's up? I'm going to be walking you through some of this stuff. This is my first YouTube channel addition to my classes, like homework videos, so hopefully that works well. If it doesn't work well, then give me some feedback. If the channel's too hard to find, or the link doesn't work, or whatever, we'll make sure that we get that going. I don't know why I tell you that. You wouldn't be watching the video to know that if the link didn't work, so whatever. Alright, what interest rate do you need to get a $5,000 investment to double? That means times 2 in 10 years. So I kind of set this one up to begin with today. One thing you need to understand is nothing in here says continuous, nothing in here says compounded, monthly, quarterly, daily, none of that. So you can assume that you're just using the most basic form of simple interest where the n is 1. Okay, it just happens like once a year. So these are the ones I kind of worry about with students that don't really prepare that much for how questions can change on you. And this one's definitely changing on you. So they are asking you, what rate do you need for a $5,000 investment to become double, which is 10,000, okay? And they also tell you that you're looking at 10 years here, okay? So we cannot do much on this side. That 10 is really holding down this 1 plus r parentheses. I can't multiply 5,000 into it because of that. But what I could do is I could divide 5,000 to the other side. And this is where we see that 2 from. It takes a little bit of practice and really doing a ton of problems to really see this. But this is that double idea, like 1 plus r to the 10th. What's going to make that double? So some people just start right here, honestly. So we talked a lot about, like last semester, if you're trying to solve something that's to the 10th power, well, you'd have to kind of reciprocate or do the opposite of that. And so I'm going to raise both sides to the opposite of 10, and that would be to the 1/10. Okay? And so what happens is this side cancels, and you're left with 2 to the 1/10 equals 1 plus r. Okay? So, yeah, I'm probably going to need a calculator for this thing. But what we're looking at is 2 raised to the 1/10. Okay, if you have one of those older calculators that doesn't look like that when you push the raised button, you may want to group that so that it actually does 1 divided by 10 before it does the exponent. You should get something like 1.07. Now, if that's what 1 plus r equals, okay, we need to subtract 1 from that to really see that the interest rate that would get you there is this 0.07. And I'm surprised we're having a little bit of trouble with this. This right here would be 7.18%, maybe. Okay, something along the lines of 7.20 or something like that. Okay, so that's where we're going with that type of problem. Being able to figure out what that interest rate would need to be in order to get you to a certain place. And it all stems from being able to plug into the correct formula all the correct given information and using your algebra skills to get that value of r or t or whatever you're looking for completely alone. Okay? So, $1,000 invested, 16% compounded continuously. So, if you are studying, study words that tell you what to do. Like continuously, you should go ahead and key in on PERT. New formula. P is the principal. E is not a variable. E is a number, 2.71, and so forth and so forth. And then the rate is the time, or sorry, the rate is the percentage rate, T is the time. And then we have this word quadruple, okay? If you quadruple something, quad, except for quadratic in this case, quad means times 4, okay? So what we're looking at is you have $1,000 invested. How long will it take to quadruple, okay? So again, 1,000 quadrupled would be $4,000. That's our target. So that A is 4,000. That principal is 1,000. Okay? And then you've got your E and then your R, which is 0.16. And then you're also multiplying that by the time, which we actually don't know. Okay? So we're going to have to really think back to last semester, and I'm going to slowly creep in something that we're going to teach you tomorrow, okay? and that is natural log. How do you use logs to get what you want? Okay, so just like the last problem, I'm dividing. Okay, I'm dividing, and if you remember back with logs, I'm going to just step over here and do a different problem. 3 to the what is 10. Okay, I would use logs to do that. Log base 3 of 10 would tell me x. And then you could just go to the calculator and figure out log base 10 over log of 3. And that would tell you, 2.09 is the power. Okay, so I'm going to hit you with this one question. We didn't do this enough in class to really understand it because I didn't even introduce this, but I put 1 in there so we could get ready for the class tomorrow. If you are trying to do one with E, okay, E, I'm going to put 4 on the other side. I think that would stem a little bit better with what I just did there. E is with natural log. On a calculator, you have log and you have natural log, okay? Natural log is specifically for continuous problems, and E is the base. Kind of like with log, that's that base 10 that's invisible. You use natural log in order to do one with E as a base. So what I'm going to do is I'm going to do natural log of both sides, okay? So I'm applying that to both sides. I'm going to write that a little cleaner over here. Natural log base E, natural log base E, that's kind of understood. I don't have to write that E. There's like a little tiny E here that's invisible. You don't really need to write that though if you understand it. And then the 0.16t equals natural log of 4, okay? Well, if you remember, there's a few rules with natural log, and there's one called the swing rule. This swings to the front if I want it to. This is like 0.16t, and then now it's kind of multiplying times natural log of E, and then that equals natural log of 4, okay? So you're probably like, oh my gosh, what is he doing? All I'm doing is pre-teaching. I'm showing you something that we're going to do later, like tomorrow or next week, okay? So natural log of E, if this has an E here, E to the what power is still E, and that is 1. Natural log of E is just the number 1, okay? It just kind of cancels out, kind of, okay? So this is kind of like 0.16t times 1, okay? And times 1, I really don't even need to write it. That's what equals natural log of 4. Well, natural log of 4 is a number, and I can divide that number by 0.16, okay? And then I have the time solved for it. So I have natural log of 4, okay? I'm going to close that parentheses and divide by 0.16, and that, my friends, is how we're going to get t, okay? We're going to get t by using natural log. It's about 8.66, okay? T equals 8.66. So about 8 2/3 of a year. Okay, that's how long it's going to take to quadruple. Okay, so I know that's something you're like, don't understand that. It's okay. I'm just reminding you of some of the things like that swing rule. Okay, that's a log property. And then also that idea of like hidden bases. To be honest, again, we haven't done a lot of natural log stuff. So just hang out with me tomorrow and we'll do some of that. Okay? How much money will you need? How much money will you have in 8 years if you invested $4,000? That sounds like a principal. With this percentage rate divided by 100, of course. And then quarterly, that means that I need to be using N as 4. Okay? So on the front of your paper, I gave you all the formulas needed to be successful here. And so we need to think about the future amount. And so we don't know that. It says how much will you have? That's in the future. So let's start with 4,000. 1 plus that percentage rate as a decimal. So if it's 3.5%, that's 0.035% when it goes in here. So 0.035 divide the quarterly 4 raised to the 4 quarterly times how many years you're given, and that of course is 8. Okay, so I'm going to put that in the calculator. So 4,000 parentheses 1 plus 0.035 right? Yep. Divide by 4, and then let's raise that. Let me move my face out of the way. And again, I think it's 4 times 8, so you could do 4 times 8, but I think 4 times 8 is 32, and not like we got to be nice to the calculator. It knows what it's doing. Sometimes you want to make sure you put it in a way that doesn't mess the calculator up, and I'm just going to put in 32. So what we're looking at is $5,286 and then 78 cents. It looks like that one's going to round up. Okay. Questions on that, please ask me tomorrow. I think that one's really mostly review. Okay. I do want to possibly take just the teensy-teensiest, smallest little quiz I've ever given. Just like the basic of the basic this week, just to kind of feel out where we're at. All right. So this question's kind of out of nowhere, but I want you to be prepared for these type of wording, type of questions. It's similar, but they're really asking you for something that's more like slope in a way. Herd of elk increased from 75 in 1998 to 310 in 2005. So obviously we've gone way up in about 7 years. Okay, so find the annual percent of increase for this herd. And so I really want to think, okay, from 2005, starting at 98, that's 7 years. Okay, I mentioned that a second ago. And in terms of the change in the elk, well, it's gone up significantly, in my opinion. 310 minus 75, we've seen an increase of 235 elk, not elves, Mr. Turner, elk. But it took 7 years. It didn't all happen in 1 year. It took some time. So when it says find the annual, that means yearly. Okay. Find the yearly percent of increase for this herd. Okay. So if I divide, let's do 235 divided by 7. Okay. That is 33.5. So it's like I'm going up 33.57 each particular year. Okay. After 7 years of that, you're going to get 235. Okay. So if it's going up if it's going up 33.17 each year, well, what was that out of the beginning? And I messed up the back part of that as 5.7. But what is that out of the original? This is how I'm constantly calculating my own percentage gains in investing. I started at 75. I'm going up 33.57 each particular year. So that's going to give me a percentage. Actually, I want to use the exact value. I don't want to model that. So I've got that exact value there, and I'm going to divide that by my original value. So what I'm seeing is every single year it's going up 44.7%. Okay, so that's my value. That's my percentage of increase per year. Remember, we had to divide by the original once we knew what it was each year. Okay, this last one I want to talk about real quick. I'm going to let you do 10 completely on your own. This is the last one I'm going to talk about. Decreasing means that I would not use a plus. Okay, I'm not using the 1 plus anymore. I'm wanting 1 minus. If you remember growth versus decay, when that number that you've got in parentheses is less than 1, overall you're going to go down. Okay, and so I want you to plug in all the information that you need. I plugged in some of it for you. And then in part B, it says how many birds would there have been in 1990. Just kind of get your mind going there. You're plugging in a negative to kind of move backward in time. Okay, that was 10 years before the study began, so we can use this model to kind of back up. Okay, so if you deposit $4,500, 5% annual interest, compounded quarterly, I feel like this is something that we've all grown a little bit comfortable with over the last few days. Hopefully, not necessarily everyone, but I hope you have. So give this one a shot. When you come in tomorrow, we're gonna have all the answers up. We're gonna talk about it. I'm gonna check your work, obviously, but we are gonna do more of what I was talking about with the natural log. This is real algebra 2. Really kind of getting in there with your log properties to solve for exponents like the time that we didn't know. Okay, so I don't want you to freak you out there, but I do want to show you where we got to go in terms of depth. Email me if you have any questions. Otherwise, I'll see you tomorrow. Peace.